Hello, everyone, and welcome to this audio podcast. This is an audio podcast, sort of continuing the science of continuing the science of nephrotoxicity and V2. This is part of the special the Crux, the special the Crux audio podcast, and again part of the Chromium Colladax audio podcast sort of series. This is a chartered edition, and once again it's a Storm Robotics production with the Shientist, and basically what I'm going to do is sort of continue from sort of the sort of initial audio podcast, wherein I talked a little bit about, or highlighted a little bit around in context obviously around the basis of the science of nephrotoxicity. I highlighted a little bit about the sort of investigations in between cross-matching serology and sort of tissue typing in and around organ transplantation. And in this audio podcast, I'm going to highlight a little bit more a little bit more around sort of the context in around sort of the immunobiology, but also sort of by way of elaborating on particular terminologies specific to sort of organ transplantation sort of specialties, alongside some of the laboratory medicine techniques and investigations, and in context of some of the biomarkers as well. And suffice to say that this particular work, the original works, was peer reviewed and published, and did contribute to a book chapter in and around 2015 or 2016, wherein the collaboration was aligned to Public Health England, which was originally based in the Southwest Laboratories, in the Bristol Royal Infirmary, England, UK, and also where the works were linked to, where there was a collaboration with the Renal Patient Support Group, or the RPSG. And so the abstract around this, there is an abstract, and the abstract can be reviewed in the written sort of information about this, in the description, as part of this audio podcast. So to begin with, a little bit of an introduction on this. So scientists again, generally between health sectors, or between where there's primary care excuse me, between where there's primary care and where there's secondary care, in context of particular organ specialties, and wherein investigations in and around laboratory medicine are required. Scientists and other sort of and other sort of health professionals and specialties who work who work who work between those sort of between those sort of sectors or health sectors have generally have access to what's referred to as electronic patient records, and would obviously also need to be familiar with sort of, apart from the sort of test investigations and the results, also need to be sort of aware in and around the analysis and interpretation of specific investigations, etc. And not all laboratory data, by the way, are of direct excuse me. Not all laboratory data are of direct relevance when reporting, but a general knowledge of these is recommended in order to understand sort of the investigations that take place around sort of frontline medicine and aligned to sort of patient care more generally. And so increasingly, scientists, for example, are able to sort of immerse themselves in authorizing and validating sort of investigations in context of laboratory medicine, but also in and around in the interpretations around point of care testing or point of care investigations, or at least know or at least also know how particular investigations become more important in aligned to sort of community or primary care, more specifically primary care sort of aspects as well, perhaps and aligned to sort of a service provision in that context. So armed with specific knowledge should also allow scientists and other health professionals, of course, the opportunity to complement service users, and sort of peers and colleagues, or also known as again service providers, with the understanding of the sort of analyses that take place in everyday laboratory practices. And a few examples would be the sort of the immunology behind cross-matching, again, organ donation and transplantation or biochemistry parameters, and interpretation of screening relating and in and around particular health conditions, and so that the general public in context of public health also have a sort of an awareness and an understanding of the appreciation and the links with aligned with treatment and healthcare, intertwining the sort of the immunological bases along with biochemistry and other sort of practices in according to sort of pathology medicine. And so, therefore, scientists in specialties as themselves as well should also seek to provide opportunities so as to highlight, apart from awareness around particular investigations, etc., also to ensure that in sort of the public domain, to an extent, that there is the appropriate sort of service provision in context of awareness linked to the sort of the sort of a knowledge bases around investigation, so that alongside the awareness, service users can implement that knowledge as part of routine care where and if it is applicable. And so the aim with this works, again, this works was collaborative, and it has been peer reviewed and published in as part of a book chapter. And so this worked seek to provide an overall perspective in context of scientists, a healthcare sort of a healthcare scientist in context of sort of in context of sort of service provision in aligned to pathology medicine or laboratory medicine, but also in context of public health. So in addition, key concepts or main concepts again, sort of where in these the initial audio podcast in this particular series around the Chromium Colladax. There was a sort of a basis around certain terminology such as the human leukocyte antigen, the major histocompatibility complex, the major major histocompatibility complex. But in this audio podcast as well, there will be sort of an overview aligned to those two sort of terminologies. Again, there will be a link in relating to or sort of an awareness in and around terminologies that such as antigen frequency distribution, calculated frequency, and the utility of biomarkers to monitor sort of nephrotoxicity and efficacy of immunosuppression in context of organ transplantation. And so once again, in this audio podcast to begin with, as part of the aim and sort of the initial sort of overview, so to speak. I'm now going to highlight a little bit in context of context in relating to in relating to scientists and sort of in context between scientists and service provision between health sectors as part of this particular sort of as part of this particular understanding. So with the expanding utilization of sort of the way information and understanding around particular areas of albeit whether it's general medicine or clinical medicine, etc., and can be harnessed by the public, by service users, so to speak. There is a need to evaluate the sort of scientists role, the scientist sort of role in context of service provision between health sectors in some detail. And so research has explored the effect of availability of internet-based health contacts for patients in and around various disciplines in aligned to knowledge provision as well. And studies have found and have highlighted a significant proportion or a proportion of people or the public rely on the internet in the main, or have relied on the internet in the main to make critical health decisions, and often bring information retrieved from the internet into, for example, medical consultations that they may have. And so in this context, scientists are able to provide, once again, tests and investigations in and around particular in and around particular predisposed conditions or diseases and so on and so forth, and in line to the interpretation around those around analyses, albeit whether it's qualitative, or quantitative or semi-quantitative in context of analyses. And so, in line to this, hematology and biochemistry investigations, for example, are generally expressed quantitatively, for example, as a set of numbers. And microbiology and immunological results, for example, tend to be semi-quantitative in that reports will identify, for example, microorganisms or immunological bases that are present and describe and look to describe sort of the sensitivities in line to, for example, antibiotic treatment, or provide assay results in context of immunology, in context of immunology, and the results that relating to, for example, once again, human leukocyte antigen and the major histocompatibility, and for example, and again, where investigations are required, or indeed where frontline health professionals sort of need an understanding or an overview in context of serology. So retrospectively, in the clinical setting and through traditional groups, patients generally again, in context. So, for example, in context of informational support, where service users seek to harness information about aspects of healthcare and etc. In the clinical setting and through sort of these groups in context of service provision as well, patients can help one another adjust to experience of living with particular health conditions by exchanging sort of lived experiences, informational support, emotional and instrumental forms of support as well. So informational support can be sort of defined as exchange of advice, explanation, research, opinions, and experiences, and generally can help service providers and service users, and those that surround service use understand excuse me, understand and learn how to deal with a particular set of circumstances, for example. And so scientists in context of healthcare too need to be able to share that specific scientific knowledge base in layman context for communities to help bridge gaps in public understanding relating back to clinical scenarios, and especially to capture sort of what's referred to, at least in the UK, has been referred to as patient-reported outcome measures, including symptom status, physical function, and general well-being. Now, this then brings into the context more specifically, where in part in the previous or in the initial audio podcast in this particular series around the Chromium Colladax, there was some bases around sort of transplant immunobiology, and so in this audio podcast, I'm gonna attempt to place a bit more of a highlight around this. So only a renal donated only in context of renal transplantation and where a recipient by an identical twin will be genetically the same as per highlighted in the initial audio podcast from as highlighted in the initial audio podcast. And in all other cases, the organ or where an organ needs to be transplanted or a recipient requires a transplant, it will be recognized. It will be sort of recognized. I use that word. I use the word recognize quite loosely because it's down to the human leukocyte antigen and major histocompatibility complex in context of serology and how well tissue type is matched. And so the an organ in context of organ transplantation will be recognized by the immune system of a new host as being foreign, and by and an immune response will and an immune response, if for example if it recognizes it as foreign, then unfortunately the immune response will be such that it will be elicited to then prompt to destroy that organ. So the risk of this is reduced by ensuring that genetic sort of bases of the donor and recipient is closely matched. Again, using human leukocyte antigen or HLA cross matching and suppressing the immune system of a recipient with particular immunosuppressive agents for as long as a grafted transplant is important. As long as the grafted transplant functions, and knowing that, and knowing, and knowing, and having a sort of pathology basis around the human leukocyte antigen, HLA and MHC, is in this basis, on this basis, is pertinent, is and generally is pertinent and generally important. So in man or in humans, the MHC is known as the is in context of clinical science, um, in context of clinical science is known as the human leukocyte antigen locus. And HLA antigens vary between individuals, making perfect matching extremely challenging. Unfortunately, these antigens are also the strongest inducers of what's referred to as a T lymphocyte mediated rejection. Uh, uh, um, um, uh, uh, so T lymphocyte mediated rejection, also referred to as what is known as acute mediated rejection as well, abbreviated as AMR. And HLA tissue typing has been shown historically to reduce the frequency of AMR episodes, thus achieving more successful outcome, a more successful sort of prognosis. So knowledge of the interaction of antigens with T cells in the rejection process is essential to understanding how immunosuppression, immunosuppression is propagated. Donor HLA molecules are presented through antigen presenting cells to resting T cells that have receptors for that specific antigen. The recognition process activates the T cells that which produce and secrete cytokines, also referred to as interleukins, and express cell surface receptors to them. So, for example, a sort of well-known cell surface receptor in this context is something that's referred to as interleukin 2 receptor. The lymphocyte colony recognizes the donor HLA, human leukocyte antigen, and looks to differentiate and proliferate under the influence of interleukin 2 or interleukin 2 RA or receptor alpha in context of sort of an immunological bases, and which has also been called a T cell, or referred to as a T cell growth factor. And so cytotoxic T cells, are also referred to as CD8 T cells, bind directly to donor cells and lyse them. So look to kind of as part of the lyse as part of the sort of the attack, so to speak, on donor cells after post transplant. If there is an elicited response, then generally the cytotoxic T cells or CD8 T cells will look to lyse by sticking to the donor cells and look to destroy them at the same time. So other T cell subsets can produce or have the ability to produce more cytokines as well. So, for example, interleukin 4 and interferon gamma, which can lead to B lymphocyte involvement, antibody production, complement fixation, and macrophage infiltration as well. And so this generally results in a destruction of allograft tissue, which impairs the ability of the organ transplant to actually function at all. And so previous exposure of a recipient of other human leukocyte antigens, for example, in the form of blood transfusions, or previous organ transplants, for example, or pregnancy even, increases the likelihood of rejection episodes taking place from an immunological basis. So the risk can be quantified using what's known as panel reactive antibodies. Now, in the initial audio podcast, I mentioned there was a mention around sort of paneling techniques, and so in this context, paneling techniques are referred to panel reactive or panel reactive antibody sort of reactions, in which the higher percentage a higher percentage score the higher the percentage in what's referred to as a panel reactive antibody, the greater the recipient's sensitivity to potentially where from an immunological basis there will be sort of a hypersensitive sort of a hypersensitive sort of a reaction, and therefore causes or elicits a response in sort of a full blown sort of organ transplant rejection. So if the panel reactive antibody antibody score is greater than 85%, for example, the potential recipient is considered to be highly sensitized and may require additional or stronger immunosuppression as well, which may be wherein, for example, if for example HLA and MHC are for example in context of the full panel investigations, if for example again where the cross match is for example decent enough, but still potentially can elicit where the immune system of the recipient can elicit an immunological response, then in some cases, or there can in some cases it can be that patients or recipients who have organ transplants. So historically, on the one hand, it would be that in such cases, organ transplant would not take place, generally speaking. But through advances, it allows patients to, for example, where organ transplantation shouldn't take place, for example, in such recipients, the dosing in context of immunosuppression, it may well be that they are on, apart from a single sort of apart from single immunosuppressive agent sort of mainstay therapy, they would be on mainstay therapy plus another form of immunosuppressive agent or immunosuppression, and may well be on triple immunosuppression therapy in such cases. And so in this context as well, there is a basis where that unfortunately, yeah. So not as sorry, yeah, and so for example, the risk again can be quantified by using a panel reactive antibody investigation, in which the higher percentage of the score, the greater recipient sensitivity. If the PRA score is greater than 85%, then the potential recipient is considered it can be considered as sensitized and may require additional or stronger immunosuppression. And knowing the true excuse me, knowing the true structural variability of HLA system allows scientists and investigators in context of pathology medicine and laboratory medicine to recognize and characterize the true complexity of immunological bases sort of in context of organ transplantation. Now, in some works that was developed was developed by NHS Blood and Transplant in the United Kingdom, in the United Kingdom after there was an allocation working sort of group which looked to inform HLA typing before HLA typing prior to donor retrieval is of paramount to the success of organ of organ allocation, and some of the main concepts relating to this are still required in context of immunobiology, and wherein health professionals in context of pathology medicine or laboratory medicine should seek to share that sort of context in sort of in align to sort of public in align to the sort of public domain, and so thus sort of the public, or the sort of general public become sort of or are become aware of that, become aware of some of the aspects around sort of aspects around organ transplantation, and sort of the allocation aspect, but also in a line to sort of public health, more prospectively. So there was a document by NHS blood transplant, but not just a document, but there has been sort of updates in and around certain areas of practices between sort of organ transplant allocation, etc., and generally is available through, for example, NHS blood and transplant in the United Kingdom. Now, in line with this, generally speaking, live related organ donation, or live related organ donation, generally in context of organ transplantation, still remains or has remained a sort of gold standard, form of transplantation, and whereby a live donor traditionally, so for example, a family member of a recipient who requires a transplant consents to donate. However, a family member may not have, for example, the right immunology, owing to a recipient HLA sensitization, and so a pathway that that has been explored by between sort of clinical scientists, sort of biomedical scientists, as well as sort of other sort of health professionals that link into the sort of service provision in around aspects of organ transplantation. A pathway that can and has been considered sort of retrospectively has been the something that's been referred to as the plasma exchange program. Now, in and around the plasma exchange program, which I'll now sort of look to seek to highlight. Antibody, the plasma so there's a plasma paired exchange program that has been implemented in for example, in cases where for example, the immunological status of individuals, from a live donor perspective, where live donation has been deemed viable, at least initially. Plasma exchange program or plasma paired exchange programs have been deemed as sort of the viable pathways for individuals. So I'm not going to talk. I'm going to highlight a little bit around this. So, uh, in context of plasma and paired exchange program, antibody removal by plasma exchange has become popular to allow transplantation of very highly sensitized prospective transplant recipients. The success of these programs is generally dependent on being able to monitor the antibody removal of the antibody removal and sort of the and identify the point at which a safe level in context of HLA, MHC, and general serology levels have been reached, as well as monitoring antibody removal after post-transplant to guide to sort of help guide sort of immunosuppressive agents in at least in some regards as well. So in a plasma exchange program, a protocol would typically include something that's referred to as plasmapheresis, whereby a recipient would undergo a process where filtration of blood takes place to deplete the blood or hematology bases of donor-specific anti-hemoleucocyte antigen antibodies. Another step of this protocol may well have and to an extent has been implemented where there's low dose anti-rejection a low dose immunosuppressive agent also applied in specific cases. So plasmapheresis has retrospectively been available in most UK centres, and it has been a pathway more specifically for live related donors who wanted to come forward who wanted to come forward and donate and donate an organ. Now, suffice to say, plasmapheresis historically or retrospectively has not been sort of a sort of a pathway. It's not been an evidenced or documented pathway specifically in and around where cadaveric or brainstem dead organ transplantation has taken place. That being said, there is something that's referred to as desensitization as well. So, in context of organ transplantation preparation, um, generally it's not without its complications, albeit whether it's from a laboratory or pathology basis or from a sort of frontline or surgical perspective either. So desensitization protocols can help overcome sort of incompatibility barriers in live organ in live donor organ transplantation and provide a substantial survival substantial bases around prognosis for recipients who are offered this modality. Now, in context of plasmapheresis, so there's the terminology plasmapheresis. Desensitization is, and I'll say this, generally desensitization is what's referred to. Desensitization is generally almost like another sort of another fancy word really for plasmapheresis, although the two terminologies are kind of are used between laboratory medicine or pathology and sort of frontline specialties in sort of synonymously in some contexts, but also desensitization again also is also a basis in where it's specific to looking at sort of the barriers in context of incompatibility from an immunological basis in sort of depth. And now, in leading to this, I'm going to sort of highlight a little bit around what's referred to as altruistic donation. Altruistic donation is the giving of an organ from a living person, so from a live organ transplant basis to a stranger. So the lay sort of terminology for altruistic means stranger, or can also mean layman. Um, and so in the US, in the United States, about 2% of annual living donations have been evidenced as being have been evidenced as being altruistic. In the United Kingdom, altruistic organ donation has become sort of high profile since around 2006, when the Human Tissue Act, the HTA, set out a legal framework for anonymous donors, and out of 3,800 living donors since then. And so this data I highlight is a little bit retrospective, but put to highlight here that out of 3,800 living donations since then, 52 have been altruistic. So further, the world of altruistic organ donation was highlighted in a special documentary in 2012. There was a documentary on Channel 4 in and around early August 2012. The documentary followed the story of a young male preparing to donate in context of a renal transplant to a complete stranger, thus becoming one of only 100 British people known as altruistic donors at that time. Now, I'm now going as part of altruistic donation, desensitization, and also in context of plasma or paired exchange programs and living related organ donation. I thought I'd take this opportunity to highlight a little bit around cadaveric organ donation. Deceased or formerly cadaveric are donors who have been declared brainstem dead, as per mention, and whose organs are kept viable by ventilators or other mechanical mechanisms until they are excised for appropriate transplantation. And apart from brainstem dead donors who have formed a majority of deceased donors for the past two or more decades, there is increasing use of donation after cardiac death donors, which is referred to as DCD, and formerly non heart-beating donors. So the terminology, by the way, has sort of switched a little bit, because previous in sort of historical and evidence work, terminology used to be referred to, for example, where cadaveric donation or cadaveric donors was concerned, It used to be referred to as non-heart beating donors in sort of in and across different areas, in and across different sort of specialties. But the terminology has kind of has switched more to when we're referring to sort of cardiac death donors. It can also refer to they can also be referred to as brainstem dead donors as well. Uh, not to say completely that the terminologies are synonymous, but in context of cadaveric donation, there is where there's donation after cardiac donors. In some cases they are referred to as brainstem dead as well, and so thus to increase the potential pool of donors as demand as demand for transplants continues to grow. And so these organs have inferior outcomes to organs from brain dead or brainstem donors. However, given the scarcity of suitable organs and the number of those who die or pass away on the waiting list, or pass away in waiting or on the waiting list, any potentially suitable organs for transplantation in context of the literature and in context of sort of in context of serology techniques, as well as a sort of in context of frontline practices, for example. Any potentially suitable organ donors are to be or should be considered in sort of those particular scenarios. This now leads into a little bit more around sort of some of the more modern sort of laboratory techniques or investigations that take place as well. So until recently, the most sort of available, the most used or available technique used relied on techniques in context of pathology medicine, laboratory medicine, and immunology and immunogenetics relied on the ability of antibodies to complement and cause complement and cause cell death. Complement dependent cytotoxicity, or something that's referred to as CDC, is a technique that is used that can be used to cross-match recipient against donor leukocytes or white cells or T cells, and purified from blood. If a serum sample is tested against a panel of white cells, or what are referred to as either leukocytes or lymphocytes from donors with a range of different HLA types, it is entirely possible to identify the specificity of antibodies from the reaction sort of patterns with cells carrying different HLA types. Now, this has always been an issue. Has been an issue because some tissue types tend to occur in specific combinations of HLA antigens, giving rise to a range of random random laboratory analyses and interpretations. So to effectively increase the deceased donor pool, donors after circulatory death or DCD should ideally only concern donors that would otherwise not progress onto brainstem death. So I'll say this again. So to effectively increase the deceased donor pool, donors after circulatory death should ideally only concern donors that would otherwise not progress onto brainstem death. So now, in line with this, in line with the techniques, techniques in laboratory medicine, now going to highlight a little bit around the probability the probability in and around blood grouping as well. So the ABO system the ABO system is clinically the most significant red cell antigen system. ABO antigens are expressed early in erythroid ontogenesis, but they are also present on the endothelium of renal and biliary tracts. About 30 to 50% of allogeneic hematopoietic cell transplants, or HCTs, are ABO mismatched. A majority ABO mismatch can result in what would be referred to as immediate hemolysis of red cells in an allograft, or pure red aplasia. The former is usually prevented by removal of red cells and removal of host hemagglutinins, and various immunosuppressive regimens are also used to preempt both immediate and late complications. The impact of ABO mismatch in HCT outcomes, such as graft versus host disease, for example, and survival and relapse, has still and remains somewhat controversial. Minor ABO mismatch probability increases the risk of acute graft versus host disease, but affects an overall but effects on overall prognoses are less certain and are at most small. So risk estimates of ABO mismatch are usually derived from registry data, which span years of transplantation activity with contributing effects of many other risk factors. In contrast to relatively weak effect on hematopoietic cell transplants, HCT outcomes, the ABO system is still a major determinant of outcome in solid organ transplantation, in particular renal, where nephrology and cardiology are concerned. ABO mismatch has usually been avoided in transplantation of these organs, although organ shortage has led to an increase in ABO incompatible transplants, and strategies to reduce allograft rejection risk have been devised, comparing various forms of immunosuppressive agents and immunosuppressive regimens, and wherein there is also a sort of comparisons are also made. So comparisons are also made in and around plasma exchange or selective immunoabsorption as well. And so in line with this as well, there is uh, there is there is an emphasis in and around hemopoietic cell transplants, cell transplants or HCT, in accordance to ensuring there is ABO excuse me, ABO compatibility across paneling, across paneling, aligned to sort of immunology and immunogenetics. So in contrast, in aligned to this as well, ABO mismatch has usually been avoided in transplantation of these organs, although organ shortage has led to sort of an increase in ABO incompatible transplants as well, as mentioned. And also in line with this, once again, this brings me into the a question really, where it's asked, what about probability of transplant, antigen frequency and distribution, and calculated frequency, and antibody defined unacceptable concepts. So antigen frequency and distribution is where there's comprehensively defining a patient's HLA antibody profile enables a sort of recognized antigens to be designated as unacceptable for transplantation, in that their presence on a donor organ would result in what's referred to once again as antibody mediated rejection, or antibody mediated hyperacute rejection, and as a safeguard against donor relevant HLA antibodies being overlooked on serum screening, the cross-match test between donor cells and recipient serum is performed immediately before transplantation. Excuse me. A cross-match negative result is required for a transplant to proceed. There is a table in this works that was peer reviewed and published, and generally the this table just sort of highlights, or sort of an overview around the sort of organization of the ABO blood group system, and generally speaking, in context of frequency in the UK, generally there is there is a high percentage of the population with group with blood group blood group A, Then second to that, there is a high percentage of frequency of people with blood group O, and then blood group B, and then blood group AB. Just suffice to say that the date the data, or the information I've just highlighted there, although retrospective, although retrospective, literature from sort of registry-based data will obviously highlight sort of the most recent sort of analyses around the ABO blood group system in context of for example ethnicities, as well as blood group phenotype, blood group genotype, antigens, and antibodies present. So again, this work was published in around 2015 and 16, and so the context that has just been sort of highlighted, although although somewhat retrospective, the listeners are more than welcome to search out the sort of the data through, for example, organizations such as NHS Blood and Transplant, and other sort of organizations to get some more up-to-date overviews around the blood group sort of statistics and analyses in context of that. I'm now going to highlight a little bit around calculated frequency. And so in living donor transplantation, or LDT, is more than an expedient response to a donor shortage from deceased donors. It generally offers sort of long-term allograft prognoses than does in the case of deceased donor transplantation, and offers a choice as to when transplantation is performed. So what I mean by that, in living donor versus cadaveric, it is in some contexts is deemed as deemed as less urgent in some regard, and allowing transplantation before for example other forms of treatments have been implemented, for example. And in addition, for many people with HLA antibodies, and in context of living donation transplantation, and across an antibody barrier, may be the only realistic probability or chance of individuals having a transplant. So the calculated frequency predicts the percentage of incompatible donors using what's referred as haplotype frequencies. Now, haplotypes, in context of cross-matching, just to add a little bit additional context in relating to cross-matching and serology. Haplotypes are sort of defined bases of paneling and cross-matching, where they are where haplotypes are linked to specific loci or loci on in and around the human leukocyte antigen, and aligned to the major histocompatibility complex, or MHC. So the CF predicts the percentage of incompatible donors using haplotype frequencies, for example, HLA, HLA-A, B, DR, and DQ, which are all different loci across in and around the HLA, and determined from HLA types. So aligned to calculated frequency, then there is then the antibody defined unacceptable. So in context of certain areas of transplantation, immunogenicity and alloantigen load can be reduced through minimizing HLA mismatching of donors to recipients. This is effective, or has been effective at reducing the number and severity of acute mediated rejection episodes, and is also translated into improved long-term graft, and is also translated into improved transplant prognoses. And so strategies that have been developed to improve a virtual cross-match accuracy for this for sort of transplant organ transplant populations include using sort of core laboratories specifying thresholds for assigning unacceptable HLA types, and the peer-reviewed works highlights certain specific citations as to where to find out more information around unacceptable HLA types, and I won't go into too much detail around that here, but and also where in line to for assigning unacceptable HLA types, and also allowing sites to enter two sets of antigens, one presenting the site's criteria for automatic refusal, and another that includes antibodies that are not an automatic contradiction, but could be a problem, particularly when there are several weak donor-specific antibodies. And so the question around this then is, can specific biomarkers help sort of prospectively or in the future? So I'm going to highlight a little bit around this in context of biomarkers in relating to biomarkers in relating to areas of transplantation. So in this context, biomarkers. So in previous in some previous audio podcasts, there has been some bases around the use of biomarkers to get an understanding around the ability to sort of understand whether there's for example in and around let's say renal transplantation, for example. Renal transplantation, there is a way, there are biomarkers that are used to help detect whether there can be renal insufficiency, and so and aligned to this, the biomarkers are affected by several factors, including age, and certain populations, so children or young people, older adults may require special consideration, as the normal laboratory reference ranges can can be elevated, can be elevated in some regard. In pediatrics and young patients, serum biomarkers, as per mentioned in one of the previous audio podcasts, serum creatinine, but also glomerular filtration, filtration rate in context of nephrology, and in pediatric patients, serum creatinine reaches adult levels by the time children or young people reach adolescence. And so moreover, these patients are can be at risk of developing drug-induced nephrotoxicity if, for example, immunosuppression is not titrated appropriately according to sort of toxicology profiles. So in particular, increased prevalence of accompanying diseases among older individuals in turn increases the susceptibility to the renal organs as well. And so, moreover, the use of multiple concomitant medicines use also affects renal function, or can affect renal function. Therefore, increased risk of nephrotoxicity requires sort of advanced point of POCT in older patients, or point of care testing in older patients. And the different biomarkers for renal function, for example, can be, for example, cystatin C, estimated glomerular filtration rate, or EGFR, glomerular filtration rate, or GFR, something that hasn't really been used sort of universally or globally, throughout, but however, there's evidence to indicate that this biomarker has specific advantages over sort of the older biomarkers that are still implemented. Is something referred to as a biomarker referred to as neutrophil gelatinase associated lipocalin, and again, as per mentioned, serum creatinine. Cystatin C, again, cystatin C or cystatin 3, formerly a gamma trace post gamma globulin or neuroendocrine basic polypeptide, is a protein encoded by the CST3 gene, is mainly used as a biomarker for renal. Has been used as a biomarker for renal function, but much like neutrophil gelatinase associated lipocalin, it is not universally implemented. Recently, there has been investigations for its role in predicting new onset or deteriorating sort of complications or health complications. For example, if GFR declines, glomerular filtration rate declines, the blood titer of cystatin C increases, and so serum titers of cystatin C are a more precise test on renal function to an extent as represented by EGFR and GFR than serum creatinine titer. However, again, cystatin C titers are less dependent. And the advantages of cystatin C also are that they are less dependent on, for example, age, sex, or gender, race, and muscle mass compared to creatinine. Cystatin C measurements alone, not alone, have not been shown to be superior to a formula adjusted estimations of renal function. And so cystatin C can be analyzed in a random sample, for example, of serum using for example, can be analyzed again. Can be analyzed, sorry, in a random sample of serum using particular immunoassays. And so the question then around this was how how are biomarkers relevant in monitoring nephrotoxicity and efficacy of immunosuppression, and why is it important in future practices? Now, in a previous audio podcast, there was some bases around this, but suffice to say, uh, the the main aspect here is that much research has been highlighted relating the importance of prevention, of early detection of particular conditions, for example, chronic kidney disease. And so post-transplant, in context of organ transplantation and aligned to immunohistocompatibility and immunogenetics as well, for example, post-transplanted recipients in different sort of pathology, in different areas of pathology, for example, have lymphocytes or leukocytes monitored against sort of immunosuppression protocols and regimens according to sort of toxicology profiles, area under the curve profiles, and also under and aligned to therapeutic drug monitoring as well. Testing has testing has traditionally been performed in sort of hospital laboratories. However, if services are sort of more if service provision is sort of is sort of in unison, more so than 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 collaborations to ensure to ensure that investigations are prompted in good time, are sort of smarter and achievable. So again, renal biomarkers such as cystatin C, and also neutrophil gelatinase associated lipocalin are now have been emerging as potentially useful indicators with sort of the sort of retrospective gold standards, and the 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 advantages of neutrophil gelatinase associated lipocalin undergoes glomerular filtration followed by tubular uptake, and is one of the earliest most strongly induced proteins in the kidney after ischemic or nephrotoxic injury in animals. And so this particular biomarker can easily be detected in blood and urine urine, hence is emerging or has been emerging as a predictive biomarker with potential use in risk stratification of estimated glomerular filtration rate, CKD progression, chronic kidney disease progression, and aligned to immunosuppressive therapy monitoring post-transplant, at least in some in some centers that have in some transplant centers where investigations have looked to compare different biomarkers, and because CKD has been increasing in the general population prospectively. Cystatin C may be a better a predictor of glomerular filtration rate than serum creatinine or serum creatinine or creatinine clearance in patients in recipients with CKD and patients on sort of particular mainstream forms of mainstream or mainstay forms of immunosuppression, since as opposed to the latter, in addition to being a good generally a good marker of filtration, it is not affected by, for example, age and gender confounders. And it appears that in renal transplanted recipients, neutrophil gelatinase associated lipocalin correlates well with cystatin C and estimated glomerular filtration rate, most strongly with cystatin C based formula. And so this suggests potential use for neutrophil gelatinase associated lipocalin as a screening, as both as a biomarker for screening and its weaker diagnostic performance rate. It's weak. Sorry, it's weak. The data around the use of neutrophil neutrophils gelatinase associated lipocalin, the unfortunately has caused some or raised some concerns about its usefulness from a routine clinical basis, owing to the sort of trials and investigations around it have not been sort of stratified. Point of care kits, point of care testing kits in a line to sort of detecting renal insufficiency generally have the ability to provide investigation at in real time. However, again, more prospective investigations are required to understand if point of care testing or investigations are useful. And so I'm now going to highlight sort of an overall discussion and sort of conclusion around this this sort of audio podcast. And so the discussion is thus to help highlight the sort of issues relating to sort of different sort of organ transplant specialties, sort of scientists and scientists involved in areas of in between sort of pathology medicine and laboratory medicine, for example, as well as ensuring there is the knowledge base there's a knowledge base where the general public gain more understanding in and around the premise around in and around the premise the sort of investigations that sort of take place from a laboratory basis. um, Scientists with health professionals between health sectors, as well as through developing works, developing excuse me, as well as developing evidence-based literature as well. Scientists should look to should seek to generally get get involved in providing bases around different investigations, through, for example, media and initiatives, for example, through newsletters, radio stations, and holding educational talks, etc. And there is sort of an evidence to suggest that more there is some evidence to suggest that health, that promotion in community can support understanding of some of the complexities relating to some aspects pertaining to serological investigations, etc. And so it would be advantageous to see scientists, healthcare scientists, and other health professionals participate in sort of excuse me, in video interviews, for example, as well, highlighting the importance of the investigations that relate to human leukocyte, the human leukocyte antigen, the major histocompatibility complex, and in and around antibody defined unacceptable calculated frequency, and in and around the panel reactive antibodies, as well as a general sort of immunobiology or transplant immunobiology, so thus to ultimately those in the public domain get the have the opportunity to learn and develop a knowledge bases around investigations that are conducted behind the scenes, and especially with regard to excuse me, especially in regard to major organ transplant specialties. And in line with this, and in context of an overall conclusion, scientists generally should be working in between health, in between sectors or service provision, and sharing knowledge is generally achievable, through through public health events and through different media streams to bring sort of the link between sort of areas of frontline medicine and areas of laboratory or pathology medicine as well. It is also important to share evidence-based practices, and knowledge sharing can lead to generally improve patient-reported outcome measures and improve shared decision making, and generally uh, uh, generally alongside this, I will highlight a few points of reference in the sort of description with this video, so listeners can check that information by sort of hopefully just by copying pasting some of the citations into potentially a Google search or a PubMed search. Excuse me, also um, uh, uh, and finally, really, um, that video any video interviews or media interviews with and between service providers in and around sort of in and around, for example, pathology medicine or laboratory medicine, for example, can also and should also should also propagate collaborative efforts between different industries, as well. And so with that, I draw this audio and podcast and to a close. This has been an audio podcast around the science of nephrotoxicity, V2, part of the Chromium Colladax. It's another special, the Crux sort of edition, and a chartered edition aligned to a Storm Robotics production. This has been the Shientist, and thank you for listening in on this.